Hello everyone, welcome to this Kubernetes new topic, which is nothing but security context. It is one of the important topic when it comes to the security of our pod or container or the processes which are running within the container. Most of the time you might have seen like whenever you create a pod, let's say from Nginx image, so within the pod container will get created and the process within the container will be running with a root user. And what if any attacker got access to that container? So definitely he will get access to the container via root user and he can do bad things within the container or mess up with our container, which is something we want to avoid. And most of the times like shared volumes are also mounted within the container, and if attacker got access to that shared volume as well, because a root user is a super user so can do anything within the container. And once he got access to that shared volume, definitely he can mess with that, or maybe he can change that data as well, which we really want to avoid. Okay, so for that matter we have to make sure that whenever someone log into that container, they should not see the root user, or they should not get access to a root user of the container. Okay, they should see some non-root user like 1000 ID or 2000 ID or anything sort of that. So that's where we have to make use of the security context to create a pod or a container and with a non-root user. Okay, so that the processes within the container should execute or should be up and running with non-root user. So whatever we are talking, it will all make sense once we go into the practical. So for that matter, what we will do, we will check if do we have any container up and running over here. No. So let's create one container or pod. Let's create a pod over here, name p1 from busybox image, and it is container creating. It is completed because the process within the container is now finished, so that's where it got completed within a second successfully. Now we want this busybox, a container from this busybox or a pod from this busybox up and running. So for that matter we will execute sleep command within that, so that it will keep on running for the longer duration of time. For that matter, we have to just get a YAML file for that and write some commands. I'll share with you definitely. Now let's go ahead and delete pod p1 because it's no longer required at our end. And let's generate a YAML file for this with the help of hyphen hyphen dry run equal to client hyphen o YAML. I want to generate it in the YAML format. Hyphen o stands for output, and we want to just execute this dry run equal to client, so that this pod creation will happen at client end. So it is like a dummy execution. In real time, pod will not get created. Okay, so it is just for generating a YAML file. I have generated it and saved it within this file. So let's delete some unwanted content, and so this is how our busybox will look like. And let's write some command. Which all commands are important for us, like sh, and then we have to make hyphen c, then we have to go for sleep command. Let's say I'm going to sleep it for 1 hour, so our pod will continue to up and running for only 1 hour, not more than that. Okay, and let's provide this syntactical things. So that's all. I want to make changes over here. So my pod will be up and running for 1 hour, because the process, which is nothing but sleep process, will be up and running for 1 hour within the container. So save it and let's create a pod now. And hopefully my pod should be up and running by now. Yeah, that's great. So my pod is up and running without any issue. So let's see by logging into that. And if I check the ID, or I have one more command, who am I? So I can check by which user I logged in within this pod. That is nothing but a root user. So this attacker gets access to it, In that case, he will get access to a root user over here, and you can see all my processes are running with a root user over here, and the file system is also with a root user. And this is the super user. Attacker can do bad things within the container, so that's what we want to avoid. For that matter, we have to go ahead and add certain code within the pod.yaml file so that a container will get created, or a pod, I mean to say processes within the container will execute with some non-root user. Okay, so I just exit out of that container. Let me delete that pod one more time. Pod p1 is getting deleted. Sometimes if it takes some normal more than 5 to 6 seconds to delete a pod, in that case you can forcefully delete a pod. For that matter, you just have to interrupt this deletion, and let's check one more time, do we have pod or not. It's into the terminating state, so we can delete by using hyphen hyphen force hyphen hyphen grace period equal to 0, and it got deleted already, so that's where we said we got output not found. Okay, so from next time we will directly hit this command so that pod will get deleted in no time. Okay, so I hope this much it's clear now, and now our goal is to add the security context related code within the pod.yaml so that processes within it will execute with non-root user. Okay, so let me add it. Okay, so code is available at my end, so I'll just normally directly copy this. Let me align it properly. Okay, so this 1000 is nothing but a user ID, and this is the group ID. So all the processes like sleep process will execute within this container with user ID 1000, group ID 3000. Okay, so earlier it was getting executed with a 0 as a user ID, which is nothing but a root user ID, and 0 as a group ID means root user group ID, root group ID. And that's all. Let's go ahead and save it and try to execute it. Get pod, don't have any pod, got created, and its container is this. Let's log into the pod now by doing execute hyphen it, and if I check the ID or who am I. Okay, so in that case this 1000 ID is not known to this, that's where we got unknown UID. That is okay, but the main thing over here you can see is like we got ID as 1000, and the processes within this container, nothing but a sleep process, is getting executed with 1000. Earlier it was getting executed with 0. Let me show you one more time that thing. You can see 0 is nothing but a root. Okay, because if you type ID root, so you will see 0 is assigned to this root. So always it will start with 0, and 0 will get assigned to the root user. Same for the group ID as well. But now we have just overwritten all those things, and now we are logged in within this container as 1000 as user ID and 3000 as group ID, so that if anything I have to do, let's say attacker got access to this container now, then definitely in this case he or she won't be able to do anything, because things are created with root user. And let's say if they try to delete this binary file or binary directory, let me try it out. So you can see I got permission denied because all those files and directories are created with root user, and I am over here with 1000, which is not having any permission to delete it. So that's where I'm getting this permission denied, which is the good thing, because now our processes within the container are secure, file system is also secure. That's what we wanted. Okay, so I hope you got this point over here. Why exactly do we need uh, security context and how to make use of it? Okay, there is one more thing within that. Let me show you. But before that, let me delete this pod p1. I have just done the control C so that I can make use of this big command directly and delete the pod p1 in no time. Okay, now let's see one more thing over here. Like, not all the images are supported with some non-root user. Okay, let's say if I try to create a pod from nginx image over here, let's say. Okay, I'll keep the name of the pod as this, and I want this nginx process to be run as a non-root. Okay, so definitely this is not required, so I'll just comment over here. Okay, let me comment this code. I'll align it later once we require this code. Okay, so now we are trying to create a pod p1 from nginx image, and that should be executed, and the processes within the nginx should execute with 1000 and 3000. Okay, so if I try, so you can see we got this error. Let me show you why we got this error. We got this backup restarting the failed container because by default nginx processes runs with root user only, and it only supports root user. That's where, like, if you try to execute or run nginx processes with some non-root user, it will not work. So that's where it has failed in starting the container. It means the process within the container is not started successfully, and because of that we got this error related things. It went into the crash loop back off, and it will keep on restarting till it gets successfully up and running, but it will never come up successfully because I'm trying to execute or start the nginx process with 1000 user, but it's not allowed by the nginx image, so that's where we got this error. Okay, so it's not like every time you add this and it will be secure, because we need to check the feasibility as well, like which all images are supported for this or not. Okay, so we need to try it out, then only we'll come to know. So let me delete this, and we have one more thing over here in the security context. So let me revert the changes over here. Okay, and the security context. So I have one more option I can provide over here as read-only root file system. Let's say if you cannot change the user, okay, so definitely in that case, at least you can make the file system as a read-only, so that even though if you log in with the root user, in that case as well, uh, attacker will not be able to modify any file or create or delete anything within the container. That's where I'm saying read-only root file system equal to true. So let me show you a demo of this, then only we'll get better clarity. I have just saved this file, and let's go ahead and create a pod. Is it created? It's under the creating. Okay, running. Let's log in within this pod, and I logged in with a root user because I have removed that run as user ID and run as group ID. Now, even though I logged in with a root user, but I made sure that this parameter read only root file system equal to true, this I have added within the security context. So what it will do, you can see I'm still within the container, all the things are created with root, and let's say if I try to create any file over here, abcd, it's a read only file system. Even though I'm with a root user, still I won't be able to do it because I have added that parameter under the security context, which is really important, so that if even though attacker got access to it, he or she won't be able to create any file or modify any or delete any file or directory within this. If I try to delete something within the bin, let's say it's a read-only file system, so which is not allowed. So this parameter is also much more important in this case because it will save us from accidental deletion of anything, or even though attacker got access, he won't be able to do it anything over here. So security context is mainly to secure our container, secure the file system within the container, secure the processes within the container, security from attackers end, and definitely we have to, it's a good practice to add these parameters within each and every manifest file wherever you are creating a pod. Okay, so you can add it within the deployment or stateful set for our security of our container. Okay, so I hope you got the point whatever I was talking about, and if you have any doubt, feel free to comment in the comment box. And if you like the content which I'm sharing with you, feel free to like it. It will be good if you can like, share, and subscribe to my channel. And thank you so much for joining. One more thing, I have already shared a playlist having end-to-end Kubernetes day by day, okay, where you can learn all those things from scratch, and you will get definitely better understanding of Kubernetes if you are new to it. Okay, thank you so much for joining. See you soon. Bye bye.